Variance and standard deviation. The main drawback of the range and quartile deviation is that both are based on only two values and do not consider all the observations. This we have seen in the previous slides also, how range and quartile deviation were comparing two values only. They were not taking the entire set of data into consideration. So here, to overcome this limitation or this drawback, we will use variance and standard deviation. So let's read further. The variance and standard deviation overcome this drawback as they are based on the deviations, means differences, taken from the mean. So let's study both this concept in detail. First is variance. The variance of a variable x is defined as the arithmetic mean of the squares of all deviations of x taken from its arithmetic mean. So the variance is the average of the squared differences from the mean, that is arithmetic mean. Now here we will use the Greek letter sigma to denote variance of x. We will write as sigma square. This is a symbol which we can use for variance. It is nothing but a part of standard deviation only. Further, we will see variance of x, or we can say sigma square, how we can calculate it. 1 upon n summation x minus x bar, arithmetic mean, the whole square. So what we have to do, you have to make summation total of x minus x bar the whole square and divide by n. N is number of observation. Then next is standard deviation. Standard deviation is defined as a positive square root of the variance. So here the positive square root we have to take for variance. For example, if variance is 36, then standard deviation is a square root of that 36. So the answer will be 6. So it is denoted by sigma. This is a symbol for standard deviation. Now let's see the formula. The first formula is for variance and standard deviation for raw data. For variance, it is simple, summation x square upon n minus x bar square. Then for standard deviation, it is nothing but under root variance x. So whatever answer you get of variance, just find the square root of it, so you can get standard deviation. Then next is variance and standard deviation for grouped frequency data. Means a question will be given to you in the table form along with frequency. So here the formula for variance is summation f(x) square. Here f means frequency will come here, upon n minus x bar square. For standard deviation, the formula is again simple, that is variance or under root variance of x. Or you can use one more formula here. What you can use here, under root 1 upon n summation fx square minus x bar square. In this way you can calculate variance and standard deviation for grouped frequency distribution. Now let's see one example. Following data gives age of 100 students in a school. Calculate variance and standard deviation. So age in years is given to you, that is your x. So write here all the values of x. Number of students is frequency, so frequency is given to you here. First step, add all the frequency. So here your n is 100. Then make one more column, write fx, means f into x. So 10 into 10 will give you 100. 11 into 20 will give you 220. 12 into 40 will give you 480. 13 into 20 will give you 260. 14 into 10 will give you 140. Then you can add all the value of fx and you can write here a sum total of fx as 1200. Then you have to write fx square. Now here what you have to do is you have to find first the square of x. Like square of 10 is 100. Then multiply that 100 with f. So 100 into 10 will give you 1000. Don't solve the square of fx directly. What many students do, they write the square of fx square as 100 square, then they write 220 square, 480 square. No, it is not like that. f is different and x square here is different. So first you have to find the square of x. Now here x is 11, so square of 11 is 121. Then 121 multiplied by this 20 will give you 2420. In the same way, you have to find square of all the x's and then multiply with frequency. So you will get all these values in a proper way and just add all fx square. So you get a summation fx square is equal to 14,520. Now here your first step will be you have to find x bar. You require x bar because you have to find variance. So x bar is equal to summation fx upon n. So it is 1200 upon 100 will give you 12. Now what is the formula for variance of x? There is one, you can also denote as sigma square of x is equal to summation fx square upon n minus x bar square. So summation fx square you got from here. So write the value as 14,520 upon 100 minus 12 square. So when you solve this entire part you get 1.2. So 1.2 is variance. So what is standard deviation? Standard deviation will be under root of variance x. So you will write here as under root 1.2. Now you can find the square root of 1.2, but it will be in decimal form. Okay, so you can just keep the answer like this, only 1.2. But if you get a natural number and you can find the square root properly, then you can go ahead and find the square roots. Shortcut method, step deviation method, change of origin and scale method. Here the first type is the variance and consequently the standard deviation are independent of change of origin. That is, if d x minus a. Now what is a? A is a constant. It means that a is a class mark of middle class interval if the number of classes is odd. If number of classes is even, then there will be two middle class intervals, and a is a class mark of one which will be having the highest or greater frequency. So a you have to take from the table itself and you have to subtract it with x. Then sigma x square is equal to sigma square d. Now this we will do in the question itself. Then the variance and consequently the standard deviation are not independent of change of origin or scale. Here you have to find u. How to find x minus a upon h, where a and h are constant. So what is a? Again a will be the mid value or the class mark we can say, and h is a class width, the difference between the class interval. If the class interval is 20 to 40, the difference will be 20 there. The class interval is say around 50 to 60, then h will be 10. If class interval is not given, then h is a difference between the two consecutive values of x for ungrouped data. Then if h is not equal to 0, then sigma square of x is equal to h square sigma square u. Now let's see one example and understand how to use this shortcut method. So here is the example given to you. This shortcut method will be useful when the values of frequency are quite large. So you are not using any calculator right now. You are doing calculation on your own. So we will do calculation in such a way that the sum gets solved easily with shortcut method. So here is the example. Find the standard deviation of the following frequency distribution, which gives a distribution of heights of 500 plants in centimeter. So they have given you the value of under root 6956 as 83.4. So height of plants in centimeters are given to you. So the class intervals are given along with the number of plants. Now here you see the numbers are quite large here, 145, 125, 90, 40, 45, 55. So here we will do one shortcut method. The first step will be you will find u. how to find that x minus a upon h. Here x, keep it as it is, minus 32.5 upon 5. H you got as 5 because the difference between all the classes are like 5 here, so h is 5. How you got is 32.5? See, first we have to write all the classes, then write mid value of x and frequency. So if you see the mid values of each and every term, so here the number of class intervals are, see how many, 1 2 3 4 5 6. So 6 are the number of class interval here. So here the mid value is 32.5 and 37.5. These two are mid value. Now in the previous slide we have discussed that we will select the value with the highest frequency. So with both this, the highest frequency is 90. So we will take our a as 32.5 and we will subtract that with x and divide it by 5 to find the value of u. So how this u came here? So here in the next part, your x right now, your x is 22.5 minus this 32.5 upon 5, you will get as minus 2. Then 27.5 minus 32.5 upon 5, you will get as minus 1, and keep on solving. So you got here 0 1 2 3. Then you will do f into u, multiply both this rows. So if you multiply both this part, you will get 145 into minus 2 as minus 290, 125 into minus 1 minus 125, and keep on multiplying, you will get the solution. Then f into u square. First you have to find u square. So minus 2 square is 4. So 4 into 145 will give you 580. Then minus 1 square will be 1. 1 into 125 will give you 125. 0 into 90 will give you 0. 1 square is 1. So 1 into 40 will give you 40. 2 square is 4. So 4 into 45 will give you 180. 3 square is 9. So 9 into 55 will give you 495. Now you have to add all the values. So first add the frequency, you get as 500. Then add f into u, you will get as minus 120 here. Then f summation fu square, you will get as 1420. So here your n is 500. Now here you have to find u bar first. First we have to find u bar, not x bar. So u bar is summation f into u upon n, that is minus 120 upon 500, which will give you minus 0.24. Now how to find variance here? So variance is summation f into u square upon n minus u bar square. See, the formula is same, just instead of x we are using u. So when you solve this part, you will get as 2.7824. So this is important one. Then further, now variance of u we got as 2.7824, but we want variance of x. So the formula here in the shortcut method is h square multiplied by variance of u. So h was 5, so 5 square into 2.7824. So it will give us 69.56 centimeter square. Now that is a variance, but we want standard deviation. So what is the formula for standard deviation of x? It is under root variance of x. So under root 69.56. When you solve it, you will get 8.34. So this is how you solve change of origin method. Now let's move further.